Hi guys, welcome to BUSA 2020 presentation. I'm Ernest, and today I'm gonna talk about statistical inference. So, why do we want to conduct a statistical inference? Because we want to have a big picture of a population by linking our data to a possible statistical model like a normal distribution. So how do we do it? Well, we just do a random sampling from a population. And what is the purpose? We use it to make decision and prediction, and also to produce an estimate of a parameter of the whole population. So this is a mind map of how a simple statistical model is done. And firstly, we will extract a random sample from a population, which is this part. And then we put it into our model, this part. Then lastly, we will conduct all sorts of tests like what we are going to learn today, which is hypothesis testing. So there are three main topics for today. The first one is point estimation. Second one is hypothesis testing. And the final one will be interval estimation. So what is a point estimation? Point estimation is just an estimate of a parameter. A parameter can be a mean, the shape, or the variance of a distribution. So why do we want to do a point estimation? Because it is less work to do compared to plugging in the whole population data into the model. And the main reason behind this is we can save a lot of time and save cost too. So the next one is hypothesis testing. So there are 7 main steps we're gonna do today. And the first one, of course, is just creating the null hypothesis. And the second one is an alternative hypothesis, where we will favor alternative hypothesis when we reject the null hypothesis. And the third one will be we need to find our test statistics for the model for this test, and it's just the statistics where we use it in our hypothesis test. And the next one is sampling distribution, where we use it to compare with our test statistics. And the next one is we need to find the observed value of our test statistics from the sample. Like this is different from the test statistic in point 3. And after we get the observed value of our test statistics, we will compute our p-value. And p-value is just a probability that measure the extremity of the sample that we have been observed. And the last one, we will write a conclusion out of the test. So the easiest way to learn is just to go through an example. And for the following data is just the height of 20 grass blade in the sample from my lawn. And all these are in centimeter. And so, yeah, from my previous study, I know that the average height is 4.12 cm and the standard deviation is 0.27 cm, which I measured it during winter. And our task for today is to conduct a statistical test to investigate whether the grass grow taller during summer by using a 5% significant level. So we need to compute our hypothesis. So the first one, our null hypothesis, we assume that the average height is still 4.12 cm. And the alternative hypothesis is just the average height is taller than 4.12 cm. So our test is 6, and our sample distribution for this test is it will be the average height minus the mean from previous and divide by the standard deviation over the square root of our sample size. And we believe that the sampling distribution will follow a standard normal, which is mean 0 and variance equal to 1 if our null hypothesis is true. And yeah, we need to make some assumption before we run the test, and we assume the population will follow a normal distribution with a certain mean and variance. And we also assume that the variance is known and is consistent throughout the whole year. Either during winter or summer, it will be the same. And yeah, let's compute our observed test statistics. So using the data above, we find that the mean of the sample is 4.248 cm. And yeah, we plug into our formula. It's just 4.248 minus 4.12, which is what we are testing, and divide by the standard deviation, which is 0.27 over square root of our sample size, which is 20. So we will get a observed test statistics of 2.12 here. So the p-value is because we know that it follows a standard normal distribution. So we just plug into it, and yeah, we get our p-value of 1.7%, which is lower than 5%, which is our significant level. So what does it mean? It means that because the p-value is small, there are evidence against the null hypothesis. So we will favor our alternative hypothesis more, which means that the average height of the grass is higher than the previous average of 4.12 cm. So next one, we will learn about interval estimation, and sometimes we call it a confidence interval. So it's just a range of value that will contain the true population parameter. And there are three main components. So the first one will be a point estimate. We get it from our random sample. And we need to add in some margin of error, which is a percentage times our standard. It's just a standard error, call it. And yeah, the confidence level. So if we want to find a 95% confidence level, it means that in this range of value, we will capture the true population parameter. If we do 100 times of sample, there will be 95%, we will capture the true population parameter. So from the previous example, because we know that it's a one-sided test, we just need a z-score of 1.645. As a result, if we want to compute the confidence interval, it's just we get the sample mean minus plus and minus, because it's a one-sided, so we just need to do one side, okay? So it's just the sample mean minus the z-score times the standard deviation over the square root of our sample size. And we get a confidence interval of 4.15 cm to n and to infinity. And we can see that 4.12 cm where we in our null hypothesis, it's not inside this interval. So this is also consistent with the conclusion we just made just now. And yeah, this is all for today, and thank you for listening.